Hi everyone and welcome to West Explains Best. Today we're going to be talking about simplifying square or cube roots. So this is a Kuta software worksheet. This is a very common worksheet that teachers give. So we're going to go ahead and start with some of the harder examples, because in some of my other videos I already kind of break down simple examples like number 1. So we're going to go ahead and let's start with number 5. So with number 5, what we're doing is we're simplifying the square root. So as I explained in other videos, we're trying to think of the biggest perfect square factors of the radicand, the term underneath the radical. So 256 happens to be a square root. It's 16 times 16 gives you 256. But let's say we didn't know that and we wanted to figure out if you could simplify it. So in order to simplify a radical, what I like to do, especially with big numbers, is use a factor tree. I divide by the prime factors. So I like to put the prime factors on the left, and since it's an even number, I know it's divisible by 2. And then I write the result on the right. And then I just keep this process going until I have all my prime factors. So 64 divided by 2 is going to give me 32, divided by 2, 16, divided by 2, 8, and divided by 2, 4, divided by 2, 2. Once I have all my prime factors, so if you check, all these numbers are prime, 2, 2, 2, 2, 2, 2, all 2s. What we're going to do is, since this is a square root, this is implied that we are looking for anything times itself that gives you, anything times itself twice that gives you 256, the number underneath the radical. So what we're going to be doing is, let me make this a little bit smaller, is we're looking for pairs. Since this is any number that we're looking for that multiplies by itself twice, we're going to be looking for two numbers that are identical. And anytime we have a pair, one of those numbers is going to leave the radical. This is how I like to think of it. The radical is the house, and in order to leave the house, these numbers need to have a date. Okay, and it has to be a matching number. So in this case, we all have pairs. What does that mean? If there's no one left home, meaning there's no 2 by itself, then that means there's nothing going to be left inside the radical. So we have 1, 2 leave. You multiply it by another 2 that leaves. Multiply it by another 2 that leaves. And you multiply it by the last 2 that leaves. And then we have our radical. Okay, and as we said, there's no constants, there's no numbers inside the radical because 256 was a perfect square. And as we find out, 2 times 2 times 2 times 2 is 16. Now, the reason why I wrote that blank radical is because we need to account for this x cubed. So we have the square root of x cubed. This big radical, the square root of 256 x cubed, can be rewritten as the product of 2 square roots. So now we have to deal with the square root of x cubed. Well, you could use a factor tree with that, but I think the simplest way is to think of the biggest number, the biggest term of x, the biggest power of x that is divisible by 2. So if we're looking at x cubed, of its factors, what is the biggest factor that is divisible by 2? And that is x squared. So we could rewrite x cubed as x squared times x. And since we're taking the square root of x cubed, we can write it as x squared, the square root of x squared times x. Why do we choose the biggest number divisible by 2? Again, because it is implied that there's a 2 here, the second root, the square root. So we're looking for any number that's divisible by 2 using the quotient rule. Okay, the quotient rule allows us to think of those numbers that are divisible by 2. And I explained a little bit of that in the other video, but this is just a kind of a quick way to give you a tool and so that you can get solving right away. So the reason why I chose that, and let me move this over to the right. The reason why I chose x squared is because we know that if we have a power here, we're going to divide by the index. So what's going to happen is this is going to become x. But we know that anyway because we know the square root of x squared is x. What's times itself 2 times is what the radical says. What times itself 2 times gives us x squared. Well, we know that is x. X times x gives us x squared. Now, the radical here, we can't do anything with. We can't simplify any further, so we're going to leave it as x squared root of x. So we had x cubed here. We simplified it to be x radical x, and then this is our final answer. So we can rewrite this as our final answer. Let me use a common color to show that they're united under a common flag, common answer, and that's 16x radical x, okay? This is square roots. Now, cube roots are very similar. There's just a little bit of a twist. So let's go ahead and look at one of our cube root examples. So let's go to 216, just because that one has a variable in it. So we have 216 r cubed, and we're taking the cube root of that. Now this is how we're going to start in very much the same way. We're going to write the cube root of 216 times the cube root of r cubed. We're gonna separate the variables, and if there was more variables on here, I would separate that into its own little group, and we're gonna handle each one separately, okay? But that's not the case. We're working with what we got. I'm going to do the exact same process with 216 as I did with the square root. So I'm going to factor this because I'm not very good just at coming right off the cuff with cube roots of thinking what are perfect cubes that go into 216 that are factors of 216. So I'm going to go ahead and start with factoring. So I divide this by 2 and I get 108. I divide that by 2, I get 54. I divide that by 2, I get 27. Now I can't divide by 2, but what's another prime number I can divide by? 3, and I get 9, and then I get 3 and 3. Now, something interesting just happened, and I'll explain in just a second. So now we're going to look for that all these are prime numbers, and they in fact are all prime numbers. Now, because the index is 3, we're looking for the cube root. We're not going to be looking for pairs. Okay, you don't just have to have one date to leave the house. We need to have triples. We need to have 3 people to leave the house. Why is that? Well, if we're talking about cube roots, 4 is not a perfect cube. Okay, 2 times 2 is not a perfect cube. But what about 2 times 2 times 2? The cube root of 8. Now we can take that, and that is 2. Okay, because the essence of cube root is saying what times itself 3 times gives you the number underneath the radical. 2 times 2 times 2 times itself 3 times gives you the number underneath the radical. So we have 3 2's, and we also have 3 3's. So 1 2 is going to leave the house, and 1 3 is going to leave the house. So we're going to put these guys outside the radical. Notice how there's no terms that are by themselves. So let's say we somehow had, I don't know, a 5 and a 7 here. That's unrealistic that a 3 would have factors of 5 and 7. But those would be boxed. I would box those and not circle those, and those would be left inside the house. Okay? If there's only 1 5 and 1 7, there's not a triple of 5 or a triple of 7. They stay inside the house and they get multiplied by each other. So this would be 6 radical 35. That's, oh, sorry, I forgot the cube root. 6 cube root 35. That's not the case here. We had nothing left after we circled our triples, so we just have 6 as leaving the radical. So we're going to write 6. I'm going to leave the cube root here. And now we need to figure out what's going on with r cubed. Now, r cubed, we're thinking of factors of r cubed that are divisible by 3. Well, r cubed is a factor of r cubed times 1. So we're going to rewrite this as the cube root of r cubed times 1. And really, you don't need to write the times 1. So we're just thinking, well, why did we choose r cubed? Well, we chose r cubed because the cube root of r cubed is just r. So this is r cubed. And we found out that the cube root of r cubed, we're going to erase that, is just r. So the answer is 6r for this one. Now let's go to an example where we do not have a perfect cube, just to end up on real quick. And number 12 is a perfect example. So with number 12, we have the cube root of 16x to the 7th. So I'm going to rewrite it. Cube root 16, cube root x to the 7th. Okay. Same thing. I'm going to factor 16, 2, 8, 2, 4, 2, 2. We're going to group How many? We're going to group 3 because that's what the index is. If it was an index of 5, the 5th root, we would look for groups of 5. So here's a group of 3. Guess what? We finally have somebody left home alone. So we're going to rewrite this. 1, 2 leaves the house, the cube root, the radical, and 1, 2 stays home. He stays in the radical. So now we just need to multiply this by whatever this is, and we're going to do that in just a second. So for any time we have a variable, we're going to think of the biggest factor of x to the 7th that's divisible by 3. Well, in this case, it's going to be x to the 6th, because x times x to the 6th equals 7. You're just thinking of essentially what numbers add up to 7, and then which of those numbers is divisible by 3. And the reason why I'm using like the what numbers add up to 7 is that's the product rule of exponents. Okay, with like bases, exponents, you can add exponents when you multiply. Okay, so just giving you a reason why I'm doing that. The reason why I chose x to the 6th is because the index is 3. What does that mean? Well, that means I'm going to get x squared when I take the cube root of x to the 6th power. Okay. And the reason being, x squared times itself 3 times. X squared times x squared times x squared gives you x to the 6th. Okay, so if I'm only looking for what times itself 3 times equals x to the 6th, that's only x squared, and that's why that's left by itself. Now, you're going to notice that we have a cube root left inside that we can't simplify any further. We're going to combine these. This guy's going to come down here. Anything underneath the radical gets multiplied. Anything outside the radical gets multiplied. So as we multiply these two, look at that nice little bracket. I can teach you guys later if you want how to make beautiful brackets. But anyway, we have cube root of 2x inside this radical, and there's our final answer. Hope you found this video helpful, and I'll see you